And I did put mine on vibrate before I walked in here. I should have just left it on there from earlier. And CRC actually comes up in this chapter. I knew I saw CRC somewhere. So now in chapter 5, you're actually looking at the switch configuration. Remember on the switch to configure it. What have we got to do when we turn the switch on and we want to go into configuration? What's the first command you're going to do after you log on, if you need to log on to the switch, although y'all don't have to because we left them open? Enable. And if you're lazy like me, what would you type instead of enable? Okay. So we can abbreviate the ENA, right? And skip the BLE. So we can cut our typing in half. The book seems to stay with the longer words a lot of times, but a lot of other books are going to stay with the acronyms, typically. And just give you a short one. If you're talking with people that do it out there, some of them, if you asked some of them what it was you typed in to start with, they have no idea in the world that that's enable they put in to start with because they've always done ENA. Okay? Once you get into the privileged mode, which is what ENA does for you, it takes you from user mode to privileged mode. What's the next command you got to do if you're going to configure that thing?
T.
Config T, which was what? Configure terminal. Okay, very good. Y'all know a good bit of stuff right here. Y'all must have had a decent instructor last semester. So they go through initially, they tell you about how it powers on. Remember, the switch and the router are actually computers. Okay? So they're going through the same process your PC goes through. And for that matter, your phone. When you turn it on, they're all doing the same type thing. If they're older machines, and your switches and routers actually are going to do this way because they're not going to do the new way, is that they're going to go through and do the post test. Okay? Because they're going to run off BIOS. Your PCs today, instead of using BIOS, what are they using? The UEFI. Okay? And where it's got it built in there instead of as a separate configuration file with what it goes through and figures out about the devices. And it's a faster way to do it and a more secure way because it's actually built into the firmware. Okay? Where post with the BIOS, that it was actually pulling a separate little file stored on your computer, and if you were somebody that wanted to mess machines up, it made it easier for somebody to mess with it. Okay? And I'm pretty sure it's UEFI.
Okay, I was going to ask you, I didn't want to disrupt the class, so I just tried to look it up. Yeah, I didn't want to disrupt the class, so I just want to look up what UEFI stood for.
Did I get the right letters?
Unified Extensible Firmware Interface.
Yeah. And remember there, firmware is the key in there. Okay? That you're storing it in the firmware now instead of in a separate little file on the computer that it builds from, which is what BIOS did. Okay? Because remember, the BIOS used the CMOS to actually do its work off of. And you could go in and change the CMOS settings. And remember, with the BIOS and the CMOS, if you want to set the CMOS back to its beginning value, you went in there and pull the battery out of the machine, or find the jumper spot where you could set the jumper, change the jumper setting, restart the machine, and it cleared it out, and then set the jumper back, and then build it and save it. Both of those becoming obsolete ways of doing because that's dying on there. However, the router and switch is still using the BIOS post method. Okay? So that in the course I'm taking that they just showed me today about the boot sequence, and they show you the two because you do have machines out there, and you can actually still use post BIOS on the UEFI machines, but you want them to use the UEFI instead of the post bias because it's more secure. Okay? So on the switch, you're going to power it on. It's going to go through the post test where it checks the equipment, make sure all the different pieces of what it's got right there is working. Now remember, it used to flash up on your screen for you on the older computers that you had from just a few years ago, and you may still be running one of those that sits there and tells you that it's looked and checked the memory, it did check to see if the hard drive was really there, etc. And then it goes and finds the master boot record using that way and boots from there. Using UEFI, it does not use the master boot record, but it knows exactly where to go to and doesn't have to go look to see where's the master boot record. On switch, it's still using the master boot record, which tells it where to go get that operating system to boot from. Okay? So on here, it's going to go and get the bootloader software, which is going to get us the operating system loading onto your switches and those. And so then it's going to also initialize the flash file, which gives it the configuration for it, and that it's then going to bring it on up. So they take you through that whole part. And you can actually tell it to boot from a different spot instead of from the flash memory. Not a big one that you got to remember on that. They tell you that if you have a system crash, you can just reboot the whole thing. It works just like you do with the PC. If you have a system crash, first thing try to do is just turn it off and turn it back on. And a lot of the time, you fix your problems right there. They talk about that there's LED indicators on there. That's going to vary entirely by switch of what LED indicators you have. You've got at least one that tells you about power, probably one that tells you what speed you're operating at, of whether you're doing the 10, 100, or 1000. Although you don't always have it on there. Sometimes that's just invisibly inside kept. If you did have a redundant power system connected to it, there may be an LED tells you about that, but you may not. It may tell you whether you're running full duplex or half duplex. If you're running gigabit speed, you are running full duplex. If you're running 10, you're running half duplex. If you're running 100, you could be running either one of them. Although full is going to give you a faster 100 than a half is going to give you. Power over Ethernet, that's what I talked about actually just briefly in the other chapter that wasn't there but I mentioned about. That is saying that we supply power to devices across the Ethernet connection. Now I said now it's even expanded further that you can provide power to some wireless devices wirelessly. And I don't know about y'all, but that just seems strange that we've got power floating through the air and can get it to devices now. But it's where they're running on just very minimal battery type things, and instead of having to have a battery there for them, you're supplying the power to it, and it's a very minimal charge it needs on it. But power over Ethernet is a definite growing trend out there. Instead of you having, so that means you go put a device in somewhere in school, we don't have to have an electrical outlet there right there for it. We can send the power to it across the Ethernet connection we've got to it. And that's nice, because the way it used to be, you go to put an access point in or whatever, half the time you had to go get somebody to run an electrical line there or run a bunch of extension cords to get there to get power to run that thing. Now you could actually do those things off power over Ethernet of just run that one internet, that one network wire to it. Okay, then they go into, they talk about there's duplex connections, half duplex. What's the difference between half duplex and full duplex?
Full duplex is gig.
Full duplex says we're doing both directions at the same time. Half duplex says we do one direction one time and the other direction at the other time. Telephone service has always been full duplex. Because if we go to talk on the telephone, so I get out my phone and call Aaron right now. We can both talk on the phone at the same time and hear each other both while we're talking each other. Does that make sense? That's full duplex. Half duplex is like when you use a ham radio or a CB radio. You're only doing one or the other on it, but you can't do both at the same time. You can listen to the other person, or you can talk, but you can't do both at the same time. Okay? That's the difference between half duplex and full duplex. Full duplex is going to be much faster. They talk about the auto MDIX port, which is what you have. Most of your ports on your switches and routers nowadays are auto MDIX. What that means is, remember what I told you about when we learned how to make the cables. Because the two primary cables y'all made that we said you would use the most is going to be your straight through and crossover. But what did I also tell you about the crossover? It's becoming obsolete because of that auto MDIX port. What that's saying is the port sits there, and when something's plugged into it, it looks at the traffic and decides which is the receive pins and which are the transmit pins. Where before, you had to have, if you connected two routers together, what kind of cable do we have to use to connect the two routers together?
Well, they're like devices.
Huh?
I said they're like devices. They're the same.
They're like devices, so what cable goes there? Or if we want it to connect two PCs together, we're going to use a crossover cable because they both have send on the same identical pins on both ends. So you can't use a straight through, because if you used a straight through, the send on one end is the send on the other end, and when they send something, they're going to clobber each other. There's nobody to receive it. Okay? The crossover switches those two sets of pins. Now, with the auto MDIX, instead you can use a straight through cable for everything. Because if you're connecting, if you got an auto MDIX port on one of the devices, the other one doesn't have to have auto MDIX on it, okay? And you connect two like devices together, it goes, oh, okay, I got to switch these two pins so I get it correct in here, and it does the crossover for you automatically. If you connect the router and the switch together, you normally would use a crossover to do that, but if you had an auto MDIX port sitting on one of the two, you could use a crossover cable there also, which in the past would have never worked, because then you would have ended up with the same mess we were talking about a moment ago. Because if they're different devices, and remember the biggest part of it is to look at back to your 7-layer OSI model, if it's devices on the same level or on two levels up from it. So if it's devices on the 1 layer, if both of them are on the 1 layer, you had to have a crossover. If it was devices on the 1 and 2 layer, straight through worked on. But if it was devices on 1 and 3 layer, you had to have a crossover again. Does that follow on you? But if they're on adjoining layers, you had to have you could use a straight through on it. But if they're on the same layer or skipped a layer in there, you had to use a crossover also, because they're pinned exactly the same. And that took me a while to finally figure out about that part. They told us about routers to routers, switches, PCs to PCs, but then when I finally figured out what really works off of that whole model we were working from in the first place, is why you've got which devices, which type pin connection on them. So, but when they got intelligent, you got an intelligent port there is what the auto MDIX port is. It looks at it and says, okay. It listens on both the listen on the send and receive and sees which one did I actually receive something on, and so that's got to be my receive wires, and the other one's automatically the send wires. So it sits there and listens on both of them and decides which one is really to receive. Whereas before it was fixed for you and it didn't have it, but the machine's getting more intelligent. They then go through and mention to you several commands you can use to see to verify things on it, the various show commands. And if you remember when we first started doing the switch configurations, I told you the show command is probably going to be the one you're going to use the most all of anything. Okay? The show running config is probably the one of all of them is the one you're going to use the most. Okay? That shows you the entire running configuration. And remember, the startup configuration is the one that's stored on the device. The running configuration is what is the actual current one. So you could have made changes in the configuration, but if you haven't saved them yet, so you haven't done the copy run start, then you've got two different configurations out there. The one that's actually running versus the one that's actually stored on the device. Y'all follow on that? So you got a show run and a show start, and they show you as the full linked ones on that of show startup dash config, show running dash config, but remember it can be abbreviated to show run or show start, which is what most of the time people do with it. Show interfaces, that one you can show all of your interfaces with show interfaces or show INT, or you can just show a specific or several specific interfaces by doing show interfaces and then the names of the interfaces you want to know about. Show flash will actually show you the configuration file that's showing that it's sitting there, not the configuration file, but it will show you your directory of your flash memory. Okay, so it's going to give you information about the flash memory, sort of like the dir command in DOS, okay, or in Windows, that you've used that one at times somewhere along the way. You don't use dir as much anymore, but it's where you could go in Windows Explorer, it's giving you the same type of information. Show version just tells you what's the version of the iOS that you're running on this machine. On Windows, you've got a similar command. What's the command there? If you go to command prompt, what would be the command you type in, and it will tell you the exact version of Windows you're currently running. Anybody know? Version or VER? If you do that at command prompt, it'll tell you the exact version of Windows you are running. Updates on Windows now are actually given to you. The number they assigned to them is actually the month and the year that it was released. Okay, they used to be a sequential number, but now they're using a month and a year. Two-digit number. Show history just gives you a list of all the commands that you have entered on there since it was last turned on. And I think it keeps either 30 or 100 of those by default. Show IP gives you information, the IP protocol information about an interface. So that's going to give your addresses and that type stuff on an interface. And then show MAC address table, or you can just do it as show MAC space address dash table. So it's got two ways that one will work. Gives you the MAC address table. That's a command. I don't think I've actually ever even used it, even in lab. Okay. The rest of those I've all used at times. Show history can be extremely convenient, but remember the other one on show history, if you want to just go back commands, remember your up and down arrow will move you up and down commands backwards and forwards to go back through the history. But if you do show history, it'll just give you a list of all the commands you've entered, which can be helpful at times that you're going, wait a minute, what was the command really supposed to be here? And then they go through and tell you about those. Remember the shutdown or the no shutdown command, that when you make changes to an interface, you want to do a no shut on it, which is no shutdown, which says start the interface. If you don't start the interface is sitting there turned off. You have to turn the interface on, and you do the double negative to turn it on. That apparently they were hanging around with the Microsoft people at that point, who decided when they did Windows that when you want to start up when you want to shut down Windows, you go to the start button to shut it down. And then I told you about last week about where they've now made when you choose to shut it down, doesn't mean you shut it down anymore, you've just sent it into a sleep hibernation state. And that was actually my article I wrote Sunday afternoon for the newspaper this week, depending on what papers publish it, and for my other publication places. And I may well put that one out on the discussion boards in all my classes, because I think that's interesting information for computer students, that it's not something you really probably already knew. Then they talk about the different issues you could run into out there, and show interfaces will actually tell you what all your interfaces are, and will tell you about the traffic that came across. It will tell you how many runts it's encountered in the last period of time, how many giants were on there, and how many good frames came through. So if you can use that one to look there and see, are you having a large number of runts or giants? If you got a large number of runts on there, you're having a large number of collisions, and it's time to break your collision domains up. Or the biggest thing in today's environment is go get some more switches, or split this stuff up where every device has its own port on the switch. Okay? And you can get rid of those runts. So that's not as big. The CRC one, they mention about that. That's mentioning that somehow the frame has gotten damaged in transmission. Those of you that go back to dial-up days, we used to see CRC errors pop up on our little indicator at the bottom. That if we had not a good connection, you'd see it flashing lots of little red. The little red light on the connection at the bottom of your screen would be just a flashing. And what it was telling you was you were getting lots of CRC errors. And a lot of times when you had that occur, your best bet was hang up and make your dial back in again and make a connection again and get a better connection across there. That you had gotten on one of Jeffrey's bad wires over there in Dade County that he's got running underwater or something. In my case, it was the wire in front of my house was running through a pool of water. I knew every time it rained, because it would start shorting out and I'd get lots of CRC errors, because they had an unprotected wire running down into the ground, and rain didn't do it good. They get into switch security some also. If you're going to access that switch remotely, you want to use SSH to do it. You don't want to use Telnet. If you do Telnet, everything's going across them plane traffic. And Jeffrey can sit in his office over there at the telephone company and watch all of our traffic. And if I send him my credit card number, because I've decided he can buy something for me, that Jeffrey will sit there and see my credit card number go across and go, well, if he's going to buy something using my credit card, he might as well get something nice too while he's at it. If we do it with SSH, it is sending it across encrypted on it. And so much for Jeffrey being able to realize I just sent my credit card number. So you really want to use SSH normally on that. There was original SSH, and now there's SSH version 2 out there, and it uses a longer encryption code behind it. And I don't remember the links of those, but you can actually look on your machine with show IP SSH, and it'll give you how the SSH is set up. And you can generate your keys accordingly. And that's the length of your keys depending on whether you're on version 1 or version 2. The longer key you have, the more secure it is, and the harder it is for somebody to break it. And then they mentioned a little bit about port security here, a couple of things to be aware of. Secure your unused ports, basically turn them off. If you don't have anything plugged into a port on your switch, have that switch disabled. That way, when I walk in there and see the switch sitting there and go, ooh, neat, and pull out my nice little Ethernet cable I carry around with me in the pocket all the time, which I don't, that I can't just plug into either one of those unused ports and then start doing whatever I want with my laptop that I've just plugged into there. Okay? That if you disabled it, you've made your switch a lot more secure there for physical purposes. So shut them down. Sticky secure MAC addresses is where you've assigned one that when it learns it, it keeps it. When it's sticky, okay? Instead of it forgetting it when you turn your device off, if you did a sticky, it's going to remember it next time you turn it back on again. And so it won't go and grab another different address. It stays with the same address. And that's basically what it's telling you about on the sticky. And sometimes you want them to be sticky, sometimes you don't want them to be sticky. And then you can enable port security on a port to making that port secure for several different purposes also. So they talk about that a little bit there for you. And about how you can check those with the show port security interface and which interface it is. And that when you do protect on there, that says, okay, we're only going to allow a maximum number of MAC addresses be built into the table, and we won't let it get any bigger. That stops it from being flooded. But you can't do flood attacks on there. Likewise, you can do a restrict on there. That then it says if packets come in that have unknown source addresses, we drop them. That if something comes in that it doesn't say where it came from, we don't want it. Otherwise, you'll let them through that. You could let through stuff that way. And then the shutdown one tells it, shut it down when certain violations occur. Let's just stop this whole thing. We've got a problem there. And so they go through and show you how to do that stuff. And guess what? We have just finished Chapter 5. I'm not going to keep y'all till 9:30 tonight. Because 4's not due till next week, 5's not due till the following week. So, and that actually means we're halfway through the book at this point. Okay? So, we've got 5 chapters left, and I say we still got 2 more nights. And if we're doing 2 chapters a night, we're going to pretty well cover the book by the end of June. And as we're getting, so I will go ahead, again, 4 is due next week, but 5's not due till the following week. I will do just like I did on the other. I will go ahead and move Open 5 up now for you, so that y'all can do it this week if you want, since you've heard the lecture for it tonight. You don't have to, but you can, okay? So I'm giving y'all flexibility, and then we can move on through 6 and 7 probably next week or whatever. And we may be able, y'all may be able to actually finish it all out at the end of June. So we may actually, what I may do, given all of that, I may actually have y'all sit there that last night of June for a few minutes that night and connect a couple of devices together for me. Okay? Because we still got stuff on through here, but we're moving on along, and if we can at least cover some of the stuff, and we've done some of this before. But it's just coming back. Notice what we did tonight. That stuff fell back. Now Aaron may be sitting there going, since it's been a while since he took the other course, having to remember, but the three of y'all should click real quickly. That you're going, okay, yeah, we talked about that just last semester. And so if you want to go on along at the rate we were, or if y'all want to go faster, that y'all can actually go faster. In which case, if we get through, speed on through to that point, I'll go ahead and give y'all a distance there to do the final exam. The lab final is actually already out there for you, that you can pull it and start working on it if you want. And you're actually going to build the whole thing in Packet Tracer for the lab final. There is no pre-configured file for you, so you've got to create a file in Packet Tracer and grab your devices and put all your devices on there. But the paper final of it that gives all your directions has the layout there for it, so you know which are the devices you got to put on there and then how to wire them together, just like you've been doing. Okay? Questions? If not, if y'all don't have anything else that we need to do, I'll let y'all go. That somehow we speed it through this thing tonight. But then, like I say, Chapter 5, a lot of what was in Chapter 5, one, a lot of the pages, if you notice, wasn't a whole lot of print on them. It was prints of the screen, showing you it on the screen and then telling you in text. So there wasn't that much material in that chapter, and now it was a little longer because it was, well, actually, yeah, because it was close to 40 pages. It was about 38 pages. Chapter 4 was only 20 pages long, so it was short anyway. But Chapter 5, a good bit of what they're going through in there, you've already done, because y'all configured switches several times last semester. So it wasn't new, and it used to be in the previous curriculum, that was new material for the students at that point, because they hadn't, it didn't used to be, it was only in the last chapter of the book they mentioned about here's how you configure a router or a switch, one of the two. And then, but they really didn't have you do it. And so you weren't doing it till you got into this course. Now you actually have done some of it, so you're already ahead of the game on it.